Hello, everybody. Welcome to our fifth fireside chat for the Vercel AI Accelerator. Today we have Jay with us, who's a director and engineering fellow at Cohere, who are an official sponsor of the Vercel AI Accelerator. They've kindly given everybody credits, and Jay's here today to talk to us about generative AI. And Jay has a pretty cool YouTube channel if you haven't seen it, and he has a pretty popular machine learning blog as well. He's helped millions of engineers visually understand ML tools and concepts from the basics, NumPy and pandas, to the cutting edge stuff with the more recent, transformers and GPT-3. He also advises Cohere's customers and developer communities on how to apply LLMs to their applications. So without further ado, thank you so much for coming, Jay, and please take it away.
Thank you so much. That was a great introduction. It's great to be speaking with everybody here at the Vercel AI Accelerator. Congrats to everybody who's qualified, who's going through this program. What an exciting thing to be a part of. Feel free to stop me. I'll be sharing my screen and sharing just a high-level look at these slides we can call large language models as building blocks of intelligent systems. Now, I understand this is an advanced group, so some of this is probably something you have heard before, but there are a few ideas that I'd love to emphasize that are usually, I find interesting to developers and builders. So if you've been following technology, we have these jumps every 10, 15 years between the various technologies, and they create new opportunities. And it's very clear to, I think, everybody on here that generative chat and large language models are the next big jump, on par with things like web apps and mobile applications. And in the past, developments, in the history of humanity, developments in language technology have been dramatic for the entire species. So the invention of writing, which is a development of language technology, is literally what we call the beginning of history. History was when we sort of started writing down that. And so when you think about, okay, this milestone of machines being able to generate and understand, quote unquote, understand a text, it could be something that is at that level. And when you think about it in the very short term and how that translates to businesses, a lot of it is about how unstructured data, which is the vast majority of data out there, these models can turn into structured data. And that can improve existing systems, but it's also going to be creating new categories, new kinds of systems and new industries that didn't exist before. I'm Jay. I write about language models. We just announced this book I'm co-authoring called Hands-On Large Language Models. You work at Cohere. This is let's say the illustrated transformer is the article where I explain transformers. Transformers are this paper, or like introduced in this paper called Attention is All You Need. And one of the co-authors, Aidan Gomez, is the founder of Cohere. So the team here has been training large language models and deploying them of various kinds over the last 2-3 years. And I'm happy to sort of be sharing a little bit of how we think about that. And the goal, the main focus of Cohere is more on the enterprise side. So it's empowering developers and enterprises for building with these language models. So we have new capabilities, but now is really the time where we see there's so much potential for the next generation of companies. So what you're doing of investing your time in an accelerator that explores these kinds of new business models, business plans, products is the right thing to do. And if you're just coming to this field from hearing about or being exposed to generative chat, so these are like chat GPT like systems that the entire class, let's call it generative chat. A lot of people tend to think of that as just a monolith. And one of the most useful skills to start to build with LLMs is to think beyond the monolith, the black box, and to not think of these models as one brain or mind that you ask about preferences, but rather a better perspective is to think of them as this two families of capabilities: language understanding capabilities and language generation capabilities that you can use to build software systems, just like you use regular expressions or Next.js or any other sort of tool in your possession. You sort of use them to compose various systems. A better breakdown of some of these capabilities is something like this. So once you have text that you give to a system that uses large language models, there's a understanding part that tends to be embedding. We'll talk a little bit about embedding. And then after that, you can do multiple things. You can generate. So generative chat is only one of multiple generation use cases that include summarization, copywriting, and other things. But there are also other very exciting things that large language models do, and they push the state of the art of what was possible with these types of system. Kind of like neural search. So semantic search is this idea of searching by meaning. So going beyond just keyword matching, which was how we used to build search systems before large language models. And that's a major capabilities of large language models to improve search systems and improve the user experience of search system. And then another thing is like building text classification into existing systems that deal with text. And so if a software system is able to determine, okay, is this message, is this for sales, for marketing, is it for somebody else, and it automatically tags it or routes it to the right person. The general example here is sentiment, so classifying things by sentiment, but that's only one axis. You can classify text across many different axes, like topic, like other things. And the more you grasp that, and language models are some of the best classifiers, and that sort of builds things that are a little bit more reliable as language model applications. Let's talk a little bit about semantic search, and that's the idea of search by meaning, where you're not just comparing the words. So if you have a query kind of like this one on the left, Brazil to USA travel visa, if you have a system that does just basic keyword search, a result can be this USA to Brazil. It has the same words, but the order is switched. While with semantic search, when using large language models, they capture more of the intent and the context of words, and those representations allow you to have things that are a little bit more intelligent in how they retrieve text. And this is one of the most exciting use cases of using large language models or language models in general for search. Semantic search can be broken down into these two major capabilities. One is called dense retrieval, and one is called re-ranking. Dense retrieval is this idea of searching by embeddings. And embedding is a vector. It's a list of numbers that capture the meaning in a text. So you have a message, you can throw it at that language model and get to that list of numbers that capture its meaning, and then you can do useful things with it. And dense retrieval is one of these things. So if you have a system like this, if you have a query, you can do this semantic search by dense retrieval, which compares that query to the text that you have in your text archive and then gives you the top search results, the most similar text to that query that you have. Now, what happens behind the scenes is that the query that you have is sent to a language model, and then we retrieve a text embedding for that text. Then that is sent to what can be called, a vector database or a vector search library. We can talk about the differences between these things. I'm sure some of you are building with these. And then a nearest neighbor search is done there. And then nearest neighbors of the search query will tend to be the best search results. This doesn't happen with every large language model. This happens specifically, language models that are geared or optimized for search or retrieval do better at this, because they are trained to embed questions and their answers to have embeddings that are in a similar space. They don't have to be syntactically, let's say, their semantics don't have to be similar, which is a general question if you use something like BERT, let's say. Yeah, go ahead, Dan.
Yeah, so our last fireside chat was actually by Pinecone, and they told us how to kind of take something and embed it and kind of try to do this vector similarity search. I wanted to ask from Cohere's perspective, because I know you guys offer, an API for semantic search. Is that just, do you guys abstract all of that away? The fact that you have to create your own vector store and embed it and do that whole process, or how does that work?
Yes. So Cohere is a model provider. So we offer large language models on the cloud. So we offer the embedding part. So we have models that are both generation models and embedding models. So these are the two families of models. And our embedding models are specifically geared towards search and retrieval. Our embeddings team is led by Niels Reimers, who created Sentence Transformers, which is one of the leading, maybe the leading open source embedding sort of library out there. And so the team is sort of geared it specifically for text embedding. And so that use case is one where, you don't have to worry about training a model, fine-tuning it, optimizing it, uploading it, and having it serve. You can just throw the text at the API and get an embedding vector back.
Very cool.
And so the embedding model, we have a bunch of them, but this is, let's say, the leading one is the multilingual embedding model that we described in this blog post. It's the state of the art on multilingual search and retrieval. So this supports 100 languages, and this is a big deal. So traditional search systems are really optimized for one language, where they do things like, you want to process things in a specific language that a lot of companies in practice do not give the same love to other languages that their customers use, or that. So, for example, if you want to do text, if you want to do search, a lot of the times you will remove stop words. So, if a query has the word is or the, these are not usually, let's say, and so a lot of search pipelines are optimized for one language, but semantic search, or let's say having a multilingual model like this, removes this challenge, and you can serve all these languages directly. And you can also do what's called cross-lingual search, where the query can be in English, but if a result in French is the best answer to that, it can be retrieved if that is what your use case is about. We've released publicly the embeddings of all of Wikipedia. These are 100 million vectors that cover Wikipedia in 10 different languages. These are on Hugging Face. You can download them. These include, so the English Wikipedia is the major one. That's about 35 million vectors. And you can use these to build things that, if you're building something that requires factual information, or you can carve out a piece of that. So you can download the English one, throw it at, let's say, Postgres, and then you want to say, maybe, okay, I want to create an encyclopedia about Breaking Bad. And so I will get all the pages about Breaking Bad, not just the Breaking Bad page for the series, but I want every episode page. So I will collect all of these and, make an app that is very knowledgeable about that part of Wikipedia. That's something you can do with a data set like this after you import it. And so I encourage you to download and play around with that. So we talked about one of the two major ideas about semantic search. Dense retrieval is powered by Cohere's embed endpoint. The other one is re-ranking. And re-ranking is a very simple idea, and it's the fastest way to inject the intelligence of large language models into a search system. So you can have your existing search systems, hey, it's in Elastic or in something else. You can just have a final step in the end where that does re-ranking. This is what this model does, which is to say, think of your search as a pipeline of two steps. And the first step is where you retrieve or you do your search with your existing system. And then you have maybe 100 results from that search. Then you present those 100 results plus the query to an endpoint called re-rank that will re-rank the results by relevance to the query. And this tends to dramatically improve search systems without changing the existing system that you're building on top. I'll give you an example. The central idea here is the large language model is looking at the query text and the text of every result, and it's scoring them for relevance. And then basically it ranks by that relevance. And this is a model that's, let's say, highly trained on this specific data set. And this is an endpoint called re-rank that does this. So when Google, a lot of these technologies came out of Google Brain, and the transformer paper was one of them. At the time, it wasn't as dramatically celebrated as it is now. But like a few months after the transformer paper came out, another paper from a different team at Google Brain came out, and they introduced this model called BERT. And that's where large language models were starting to be able to do things that went into product almost directly. So this is almost about 6 months after BERT. They rolled it into Google Search and started serving every query in the English language using this model, and called it one of the biggest leaps forward in the history of search. And you see this going into industry super rapidly as well, where you have companies like Spotify and others sort of using models, large language models, for understanding, for re-ranking, and for semantic search. And so that's a little bit on the retrieval and understanding part. We can talk a little bit more about the generation side. So a couple of families of, let's say, generation models is we started out with what we can call the foundational language models. And so that's what gets trained in the beginning, using the language modeling objective of predict the next word. And so from that, you get this other step of fine-tuning or optimizing models to really follow commands or follow instructions. And on the Cohere side, the flagship model for text generation that follows instructions is this model we call command. And then various models based on sort of your use case, you can add these additional capabilities that are relevant for your use case. And a bunch of different use cases require different kinds of fine-tuning as well. So at Cohere, we also offer a very simple fine-tuning service where you just upload a file and we'll fine-tune a model and deploy it. And then you have your own custom model that is focused on serving that specific use case. I'll skim over these some of these slides and the upcoming ones also quickly to just leave a little bit more time for discussion and questions. A couple of cool schematics that maybe you've come across is making transcripts searchable. So you might have come across things like people who are asking questions of the Lex Friedman podcast or the Andrew Huberman podcast. Some of these demos went viral, or you can converse or ask questions to a book or an article. And the general recipe for something like this is, if you start with audio, you can transcribe that, or you can start with text. And so you have the text. Then there's this important idea of chunking or breaking down that text. This is different for every kind of text that you're dealing with. So you can break it down into sentences or into paragraphs or into any chunking that is, let's say, geared specifically for your data set. There's not one way of chunking these data sets that works across the board. And then you embed those chunks, you throw that into a vector search database or a vector store, and then you can send questions and retrieve the answers or the most relevant passages to that. So this is a common use case. And then you can do this across multiple pieces of text, but then you can also think of that as you would think a database. So if you have when you're using a vector database, so let's make a distinction between the easiest way to start with vector search is to use something like Feis or Annoy from Spotify. And these are tools, libraries that you give them the vectors, they build an index, and then you can search it. But then they only return to you the IDs, for example. They don't store the text. The vector databases, on the other hand, do a little bit more. The vector databases are things like Pinecone, like Weaviate, like Quadrant or Chroma. They do store the text in addition to the vectors, but they also allow you to do filtering. So if these selecting and filtering operations that you're maybe used to doing with SQL. These vector databases are able to do a little bit more of that, as well as some of them are able to do this hybrid search. So there are cases where you want to do both semantic search as well as keyword. And so some of the vector databases sort of allow you to do. So there's another, I really love this use case of topic modeling, which is, if you have thousands and thousands of messages, you can use language models to help you read them and understand them at a glance. And I love this use case because it uses both generation and embedding. I love these flows that use multiple of these. There are a pipeline of multiple of these. So let's say you have 100,000 tweets from some hashtag, or there may be sent to some customer service account or something. You can embed all of these tweets. You can plot them. You can cluster them. You can just use k-means clustering or any clustering algorithm. And then using a large language model, you can label them. You can have a model read a sample or some examples from that group or from that cluster, and then assign a name to them. And with that, you really use this thing that software is much better than humans at, which is reading things very quickly. So it has no problem reading 1 million or 10 million of these and giving you or allowing you a glance that uses summarization, clustering, embedding. This is a powerful tool. We have a quick guide that we've written on clustering the top hacker news and like exploring them. And you can find that if you search Hacker News Cohere, you'll find that guide with the exact code that runs through it. And so some companies are trying to build strategies either for your company or for your enterprises that you're going after. If you're not a consumer company, if you're thinking about going after, the Fortune 500s or the big companies, it's useful to think about, okay, what are the text pipelines out there, and then how can they be sort of improved? So that's one way of thinking about where these new capabilities can arise and where pain points you can identify that you can solve with large language models. And these companies and these use cases will tend to grow dramatically very quickly. And on the Cohere blog, I share a few thoughts on for you, where is the competitive advantage? If you're a company that's building on top of a large language model provider, where is your moat that other people can't copy? Because a single, let's say, prompt is really not it's not a moat. It's not a competitive moat. Where are the moats? I discussed them a little bit in this article called AI is Eating the World. So we talked about search a little bit. We talked about generation. And search is really the future of generation. Any language model that you have, if you present it with question 1 or question 2, it's bound to do a lot better at question 2 here, where you give it the context or you give it the answer in the actual prompt. And this is a class of systems that we already know. And it breaks down the language model into this. So you can think of the language model as a thing that stores information as well as has some language skills. And when you think about it, we have databases, we have systems that are able to retrieve data. Is it really efficient to store all of the world's information and Wikipedia in GPU memory and sort of retrieve from that as it's loaded into the model's parameters? Or should we sort of use this external retrieval mechanism that gives us a lot of useful things? So if we're using an external data source, we can update the information without having to train the model for another 9 months. We can use it to give different users access to different kinds of information. And then it also enables much, much smaller models, which is something that is one of the most exciting trends for me. Yes, the larger models are demonstrating capabilities, but the smaller models that will possibly land on the edge very soon, that's where a lot of capabilities will be unlocked. So smaller models are exciting, and you can get a lot of value from them if you think about this formulation of bringing the data from a different place, where the language model is only focused on language skills and not storing the world's information. And this is an area in the research called retrieval augmented generation. And it's like the intersection of the two areas where we think very, very deeply about between generation and search and retrieval. And one of my colleagues, Patrick Lewis, built a couple of these systems and wrote these papers on retrieval augmented generation at Meta. And I would like to refer you to this interview with him on the Machine Learning Street Talk podcast for a little bit more on the state of the art in retrieval augmented generation. There's also maybe my video on the retro model from DeepMind and how that works. If you want to get a little deeper into that as well, I discussed that. So that's the high level view here, I would say. So just an advice to people to think about language models as composable building blocks of capabilities that you can say, that you can use in pipelines, you can use in multiple steps, that you can use for understanding and generation and search and classification, rather than what prompts am I going to throw at this model and what output am I going to get from it. So yeah, we're training a open source. So Cohere has a nonprofit research arm, community-led. It's called Cohere for AI, and we're training a multilingual instruction-tuned model. And if you're interested in that, you can join or search for Cohere AI. It's an exciting project. And we've also launched something we call LLM University. So if you want to learn a little bit more about what embeddings are, what language models, what is a transformer, I've collaborated with some of the best ML educators out there on creating this. It's completely free, no sign up required. You can browse it. There are videos. You can go over it to just check out LLM University. You can join our Discord if you have any questions, and we're happy to sort of guide you through the learning journey. That is my talk. Thank you for listening.
Thank you so much, Jay. That was amazing. There was I don't know if you looked at the chat, but there's a lot of love for re-ranking specifically. I saw that's in beta. Is that something recent that you guys came out with?
Yes. Re-ranking is quite recent, but it's definitely one of the more exciting sort of things out there, and it tends to really improve systems quickly.
Amazing. And yeah, it looks like a lot of folks related to what you were saying. Eric in particular here is actually working on, podcast transcribing and searching. So I think that schematic you showed, he was literally like, this is exactly what I'm working on. So that's awesome. If anybody has any questions, please raise your hand or put them in the chat. I see I'll let Eric go first, and then I have a couple of questions of my own actually after. Go ahead, Eric.
Yeah, sure. Thanks a bunch. This was super great, and it's fun to see. It's fun to see some of this stuff kind of like neatly organized. I wanted to ask a question about retrieval augmented generation and re-rank. So I have two questions around that. Well, you're pretty limited by your context, and of course, as it grows, it seems like it doesn't work quite as well. What has been your experience? You show this document search, but potentially there's a large number of search results that are relevant to the given background. So, do you have experience or any issues with trying to shrink that back down? Do you rerun it again through a model? Do you do compression, further embeddings? I mean, there's stuff there. I just don't know what's out there.
Yeah. I mean, there are different strategies, really. There isn't one thing that serves all use cases. But I've seen a lot of it goes down into your chunking strategy. How are you chunking it? And so what are you retrieving back? And from those chunks, how many chunks are you presenting in the prompt? So, the easiest way is to just bring the top result and plug that into a prompt and give it. For some use cases, that is not sufficient information. So you can think about it just, I don't know, like information theory. Where is the information stored in this paragraph, or is it in this other one? Or is this a text format where it's a story, where each paragraph is meaningless on its own? So maybe I need to summarize this story and then have an embedding of this summary, which is another sort of tool in your toolbox. We have a beta summarize endpoint as well that can summarize something, and then you can embed that and you can throw that into your vector search. And so, yeah, that's a little bit of where you sort of need to experiment for the specific parameters that you're thinking of. But these are some of the general strategies I've seen.
Actually, on that topic, because you mentioned chunking, I saw a question in the chat from Sean who asks, do you have any current best practices or rules of thumb on chunking? And he said, any thoughts on how the context U curve affects how you should do specifically a retrieval augmented generation?
Yeah. So I mean, there are a couple of heuristics, but again, it depends on the actual data set. For vector search, there are limitations of the context of the embeddings model itself, one. And then there's a heuristic where there's a tendency of you should limit the search to one idea per piece of text. So the model is able to really hone in on it. And then that definition of one idea is different based on different sort of use cases, which is where we said, with narrative, for example, you can't really maintain a full story in one paragraph. So maybe you need to do this summary and then, let's say, embedding. But the general guideline is, yes, one idea per vector, and then you merge a lot of them. And a lot of people who are working with managed large language models, you work within the limitations of an API and what's possible. Maybe in some use cases, you might be better served if the language model that you have is not giving you those results. Fine-tuning is potentially a better approach for your use case. If no matter how much prompt engineering you do, you're not getting the results that you want, even though it's intuitively to you, it makes sense that the model should be able to do it. That tends to be the next level of thinking about it.
Eric, did you have another question?
Sure, I can pile on here.
Yeah, we'll do that, and then I see Raju has his hand up, so I'll call on you next.
Yeah, no, absolutely. So topic modeling is that's a very cool use case. It's something I've been considering and sort of playing with, but man, that seems expensive. I mean, it's fine for a small number of documents or whatever, but if you're going to rip through this or do it on any regular basis to sort of reprocess. So you mentioned smaller models. Are there models that work well in your experience that are well suited to the job, or can you tell me a little bit about how you approach that from a cost, of inference perspective?
Yeah, so there are two language model hits there. There's the embedding part of embedding the text, and then there's the generation part. So, I mean, the pricing keeps going down. That's a very competitive sort of area on both ends. And so a lot of the times it's, it's super, it tends to not be dramatically costly to embed things. The generation side, it can run you a bunch of tokens, and you can run through, let's say, the context length as well. And so there are also a number of different strategies. If let's say you have 10,000 tweets, and then one cluster is, let's say, 1,000 messages, do you need to throw all of them at the model that names the cluster, or can you sample a number of them? And then there are people who are thinking about, okay, which ones do you sample? Do you get things that are closer to the center, or these are all sort of ideas. BERT topic has a few really good ideas, and let's say support for a bunch of different models, both managed and open source. And the founder, the creator, the developer of BERT topic is my co-author on the book, and he's like single-handedly one of the people who are pulling topic modeling into the LLM sort of era. And so if you're interested in that use case, highly recommend you look at BERT topic and the strategies that community is sort of developing around it.
Yeah, topic modeling honestly sounds phenomenal. Like I guess a use case I had is probably back when I was in college. If I could just take all my notes and put them somewhere and just have automatic like mind maps drawn up, like that sounds incredible.
So Hassan, there's a person who did Obsidian Second Brain and then augmented it with with an LLM. So there's actually a whole universe of people who are into that mind mapping thing, which is a cool rabbit hole if you're into that.
That's amazing. Cool. All right, Raju, go ahead.
Hey, thanks, Hassan. Hey, Jay. I really appreciate the chat today. I just have a couple of questions how I can really use your models into our application. We are pretty much a headless storefront builder, right? We wanted to explore the capabilities of using our storefronts to be translated into multiple languages in real time. Right. So in this case, there's always possibility of getting some static stuff that we can translate and have it, but something like product descriptions and all this stuff that is always going to be dynamic. How well we can really explore those opportunities with your models in real time? Can you just explain on this aspect? And second thing is that there's always a possibility of prone errors, right? How can we avoid those things as well?
Yeah. I would say for the multilingual front, the embedding understanding models are the ones that are at the moment supporting multiple languages. And so that can improve your search systems rather than sort of the generation one. It's like search, clustering, classification, topic modeling, all of that can be done on that with that family. On the translation aspect, you'll probably need a multilingual generation model, which is not what's in production at the moment. Or potentially you have a pipeline of generation and then translation, machine translation. These are, two of the possible ways that I would think about it. But yeah, I think that's
Got it.
The multilingual sort of understanding model is perhaps what's the most relevant for your use case, I would say.
Sounds good, Jay. Thanks.
Great. So we have a couple in the chat. Actually, Robin, who is working on Wonders, they do AI scientific research of basically indexing hundreds of millions of research articles and kind of searching between them. So she was particularly interested in the re-ranking piece because she's showing articles when you search certain terms. So she asks, can you add parameters with weights to re-ranking?
I do not believe so. So it just will give you back the results in the proper order that it's suggesting. Usually, like with search systems, I will want to check, like, does it return a scoring mechanism? I do believe it might do that. But search systems in general, if you take a step back, you have signals. You have various sort of signals that you get based on different areas. So the areas we're talking about here are all about the text relevance between the query and the document. But some systems, you need to add additional signals beyond this. So PageRank, for example, is another signal that has really nothing to do with the text between and the similarity of the text between the query and the document. But like, how authoritative is this domain or is this web page? There are other signals of, okay, maybe show me the more popular page is a better search result here. So this is another signal that you can sort of sort by. Or if you're doing search on maps, you want things that are closer. So distance is another signal. And so you can think about search as you have multiple systems, each of them giving a signal. And then finally, you have another re-ranker that sort of thinks through how do you want to balance the various signals in your use case? There was this a bunch of articles about Yandex, the search engine, and some of the signals that they use in search. Over 1,000, I believe, were discussed online. So yeah, re-ranking, I would say it's like one of these systems that give you a signal, and then you can use that with additional with other, let's say, signals to finally give you a final result. I hope that answers that question.
Yeah, I was going to build my own re-ranking system, actually, just with like a simple relevancy calculation. So would that, I guess I'll have to test to see like how fast the model will re-rank stuff, because then it'll go through another loop, but that's not very much, I guess.
Yeah. So, I mean, that's where the model does better. That's why re-ranking really sort of does better than dense retrieval, because the model is looking at both the query and the answer. But like dense retrieval or searching by embeddings, you have a compression of the query and a compression of the document, and that similarity is done there. But the language model, when it's doing the re-ranking, has access to every word in the query and in the text while it makes that score. So it's able to do this. And like just anecdotally, a lot of these first deployments of large language or of language models to Google and Bing search were potentially more on the re-ranking side. That seemed to be the fastest way to deploy these systems.
Yeah, I do have another question, but I don't think I understood the last bit, actually. You were saying that the language models were, sorry, can you explain that?
Yeah, so when transformers were first deployed to do search, most likely they were done through re-ranking. At least on the Microsoft Bing side, there's papers and work about the kind of the re-ranker that they had that improved their search stack with re-ranking.
Okay, got it. Thanks.
Thank you.
Cool. It looks like we have one more question in the chat. Ying asks, is there a difference in 1, the world information for augmenting the search versus 2, the world information for finding the answer based on the search query? I think this is in reference to your slide about, search augmented generation versus the other kind.
I am not getting it. Maybe if I can read it. World information for augmenting the search versus world information for finding answers. Is there an example that you can provide for this? I'm not really.
Sure. What I mean is, so for example, when we are searching, the search augmented is for fitting a query into it. For example, with the pricing of something, and it will come up with some context about that, right? So that is where you need to fit into a word information about what's the price about this material. Its material is like what. But also when you are using the prompt result into for example, you have customized information you want this query to search in, and so that customized information, does that have like information overlapping with the information you feed into the augmented search query to train that search query? To output that augmented search query.
Yeah, if I understand it correctly, is with the model that you're dealing with, you will run into, is the model able to rely completely on the context that you provided, or does it mix in its world information, even if you provide it with a proper context?
Yes.
And so that's also a design sort of trade-off, where you can train a model to only rely on the context, but then if you tell it, if you give it a context where you expect it not to, let's say, deal with common sense, do you expect it to abide by the context and your command to the model to abide by the context, or do you want it to abide by common sense? And this is really something that's super experimental with the model that you have, and sort of your use case. So you'd have to run a few examples to see, is the model able to successfully separate, and this is the concept that you sort of need to differentiate of world information, the parametric memory or information store of the model, so the information stored in the model's parameters, or the information that you provide to it in a context or a prompt, and then the model's ability to rely on one versus the other when you tell it to do so. I hope that answers.
Is that similar to the idea of like overfitting kind of thing? Like, for example, if you provide, if the model information is less than the word information you provided to the search, it cannot train it well, kind of thing.
Yes. Yes, you can potentially, if you overly train the model to follow the context, you can have it overfit and sort of lose some, common sense that it needs in some of these use cases.
Awesome. Well, I know we're running over, but we'll take a final question from Eric and then wrap up if that's okay.
Yeah, hopefully this is just a quick one. Most folks, when they're talking about search, get super excited about everything going on in the back end, and there's a lot of stuff, and they're pretty hand wavy about that initial query. I'm wondering if you have any experience or have seen anybody doing any manipulations of the initial query. I mean, in effect, your initial query is a prompt, and prompt engineering, in quotes, air quotes there, is a thing. For sure. So do people tune that, or you just sort of give up and you embed it and you just call it a day and do your best, typically?
So traditional search has a lot of things. So like Google search works because there's so much that they do to the query. And these are ideas called query expansion that are part of search systems in general. Some part of it, like you take into consideration when you're designing your embedded model, where there are methods, like a couple of them. One is called GenQ, another is called InParse. What they do is that to make a model better at searching a specific domain, they use a generation model to generate queries, possible queries about every text that they have. And that sort of tries to match what kinds of queries people would use to find this piece of information. And so it's a worthy investment. If your search systems, if you do everything, if you do hybrid search, if you do semantic, you do re-ranking, and you still sort of need that improvement to also think about query expansion. And there are, it's an ongoing area of research, I would say, to improve these systems. So that's a perfectly logical path to go through and improve. There is one thing. Yes, there are generation models, and some of the retrieval augmented generation processes that take a first step of rewriting the query so that it's made better for a search system. I can maybe find you a link here, but or maybe I can send it to Hassan. Maybe you can share it. There was for anybody interested in retrieval augmented generation, there was an incredible workshop here at ACL. ACL is the leading NLP conference, and they touched upon. It was an incredible tutorial about everything retrieval augmented generation, and they touch upon all of these techniques. And so if you're interested to learn about the state of the art there, that link I found it, very visually accessible, and gives you a lot of the different systems out there.
Great. Thank you so much.
Awesome. Well, with that, I think we're going to wrap up. Thank you so much, Jay, for spending your evening with us and giving us that wonderful presentation. Thank you, everybody, for coming as well. I know it's pretty late for some folks. I think it's like 2 a.m. for you, Robin, if you're still in Ireland. So thanks again, everybody, for coming. And thank you again, Jay, for showing up.
Thank you so much.